Hi everyone, this video lesson covers part 2 of 1.6 notes. Okay, so 1.6a was set notation. Today we're doing interval notation. So this is 1.6b. So interval. In interval, you have left boundary on the graph and right boundary. And sometimes you do not have any boundaries, like for example, when it goes to negative or positive infinity. But don't forget, this is the left side, this is the right side of the graph. Okay, so with that said, let's look at this graph. So as we can see on the left, this keeps going to negative infinity, which means, notice that I'm using a parentheses, because when we use parentheses, that means this value either gets approached or the graph just keeps going. Okay, so in this case, we have an arrow, which means the graph just keeps going to the left. But watch this one. For this value, the one farthest to the right is 1, right? So then for this one, notice that the graph stops there. So the question is, how do we communicate that the graph stops there? We communicate that by writing a bracket. Okay, so if it's a closed circle, then that means bracket. If it's an open circle, that means parentheses. If it's infinity, that also means parentheses. Okay, so then on the next example, notice that on the left side of the graph, we have an open circle. So that means we cannot use a bracket on the left side. So this is parentheses for this one. And that value is a -2, which means it approaches that value, but it can't be used because it's an open circle. So for example, you can do a negative, let's see, so in this case, you would be able to do negative 1.9999 and get close enough to -2, but you can't use -2. But on the right, notice that this goes to positive infinity, so then this one also gets a parenthesis. So the point is, open circles get parentheses, infinity gets parentheses, okay? Closed circles get brackets. So wherever you see a closed circle, include a bracket for interval. So for this one, on the left, we see that it's a closed circle, so that means bracket here. And then the value of x at this point is -3. But then notice that at 0, we have an open circle, so then 0 gets a parenthesis. Next example, this goes to negative infinity on the left, positive infinity on the right, so that means parentheses on both. So negative infinity and positive infinity for domain in interval. Okay, so let's see if this makes it easier for you. I think interval can be easier than set notation because you have seen this before, okay, more than you have set notation. All right, so on the next part, for this one, this graph, when it comes to domain, left, it's not going to stop going left. So domain is negative infinity. And the on the right, it's not going to go right. It's not going to stop going right. So then positive infinity on the right. So then again, don't forget, whenever you have infinity, that means parentheses. The range, this keeps going down. So it goes down to negative infinity. So it goes down infinitely and then goes up to positive infinity, okay, in interval notation. So then, is this a graph of a function? Yes, it is a graph of a function because it passes the vertical line test. Okay, any line that I draw or sketch here, it's only going to intersect this line at one point. So the answer is yes, it is a function. Next example, for this one, notice that the farthest to the left the graph goes is at this value, which is where x is -3. And also notice that this is a closed circle. Closed circle, so that means bracket here at -3. And then on the right, this is an open circle. So then this is where x is 1. So 1, and then use a parentheses for that part. Okay. The range, bottom to top. So the bottom is 0. And notice again, it's an open circle. So parentheses at 0. And then y is 4 at this point. And that's a closed circle. So 4 gets a bracket. All right. Next one. Function or not function. This is a function again because if you draw the vertical line test, any of them is going to pass that test. Okay. The next one. This doesn't go left infinitely. There's a stopping point. So then that's a closed circle, which means that value for x gets a bracket. And this is where x is -4. And then on the right, this keeps going to the right. So that means it goes to infinity. So infinity gets a parenthesis. The range. The range, it does have a bottom. This is the lowest it goes, and that value is included on the graph. So then bracket, and the value at this point is 0, but then it goes up infinitely. So then it goes to positive infinity. So there you have domain and range for this function now in interval notation. Function, yes, please. It passes the vertical line test. You can do as many of them as you want. It's going to pass every single one of them. Okay. So let's go on to the bottom example. So example number 4. Interval again, this is going to go to the left infinitely. So that means parentheses, negative infinity. But then it gets to the right, and this is the farthest to the right it's going to go. So then this is where x is 4. And that circle is closed. So bracket at 4. The range goes down infinitely. So that means negative infinity. But then it gets up to this point, and that is where y is equal to 4. And notice that that value is included on the graph. So that means 4 gets a bracket here. So they have the same domain and range for number 4. Function, yes, you can do as many vertical line tests, and it's going to pass every single one of them. Okay, number 5, domain. This keeps going to the left, which means negative infinity, keeps going to the right, positive infinity. So then this is negative infinity, comma positive infinity. The range, no different. It's going to keep going down, keep going up. So then negative infinity and positive infinity. Function, yes, it passes every single line test you try to do on it, okay, on the graph. Next, number 6. So for this one, interval, notice this is the farthest to the left is going to go, and that value is included. So that means you do a bracket here, and the value of x at this point is 0. But then it goes infinitely to the right. So that means positive infinity and parentheses there. The range, this keeps going down. So that means it's going to go infinitely to down. So that means negative infinity, and it's going to go infinitely up. So that means positive infinity. Okay, now look at this one. Is this the graph of a function? And you should be saying, no, it's not, because you can do just one vertical line test. It's going to hit that graph at 2 points and supposed to only hit it once. So the answer to this one is no. So let's go on to the next page to finish up this lesson. Okay, so on this page, we have asymptotes. So let's see the domain. Domain, this keeps going left, keeps going right. So it goes infinitely left and right. So that means negative infinity on the left and positive infinity on the right. Okay, so there are no boundaries on this one. The range does approach y equals -1. So again, since we have an asymptote, that means we have a parenthesis, not a bracket, because this value cannot be used for this graph. So -1, comma, but then goes up infinitely. So -1, comma, positive infinity. Function, also vertical line test, is going to pass every single one of them. So the answer is yes. Okay, last example here. For this one, in interval notation, so notice this keeps going infinitely to the left, right? So then negative infinity on the left, but on the right is going to approach this vertical asymptote, and that is where x is equal to 2. But don't forget, asymptotes can be approached, but they can't be crossed, they can't be touched. So then you can't use a bracket here, use a parenthesis instead. The range, this keeps going down infinitely. So then bottom is negative infinity, and then top keeps going up infinitely. So top is positive infinity. And there is the domain and the range in interval notation. So last question is this a graph of a function? The answer is yes again, because you can do as many vertical line tests as you want here, and it's going to pass every single one of them. Okay, so that is all for this lesson. I'll see you in class. Thank you for watching. Bye-bye.